Hi, welcome to the discussion of orthographic projections. In this particular topic, we'll convert three-dimensional drawings into two-dimensional drawings, that is converting pictorial views into orthographic views or projections. Orthographic views or projections. Here, we have to get back the basic concepts of orthographic projections. That is front view is projected onto the vertical plane, top view is projected onto the horizontal plane, side view is projected onto the profile plane. That is, front view is projected onto the vertical plane, top view is projected onto the horizontal plane, side view is projected onto the profile plane. In the case of orthographic projections, in the present discussion, we are using first angle projection. In the case of first angle projection, the object is placed in the first quadrant. Object is placed in the first quadrant. If that is the case, front view is projected onto the vertical plane, that will come above the XY line. Top view is projected on the horizontal plane, that comes below the reference line, and side view is projected onto the profile plane, that will come adjacent to the front view. Adjacent to the front view. In the case of front view, we will see the measurements of length and height. In the case of top view, length and breadth. In the case of side view, breadth and height. The common measurement in between front view and top view is length, and in between top view and side view is breadth, and in between side view and front view is height. Again I am saying, in the case of front view we will see length and height, top view length and breadth, side view breadth and height. The common measurement in between two views, say in between front view and top view, is length, in between top view and side view is breadth, and in between side view and front view is height. Now we will see the conversion of pictorial views into orthographic projections. Conversion of pictorial views into orthographic projections. This is the given problem. This is the given problem. In this problem, if you observe, the direction of arrow indicates the front view. The direction of arrow indicates the front view. That means this is the length and this one is the height and this one is the breadth. That is length, height and breadth. Length, height and breadth. In the case of front view, we are able to see this length dimension and the height dimension, again length, again height and again length, whereas this breadth dimension is point. Again this breadth dimension is point. Why it is a point? Because it is perpendicular to the observer. That is, breadth is perpendicular to the observer in front view. Even this breadth line also perpendicular to the observer in front view. Even this breadth line also perpendicular to the observer in front view. Even this one also perpendicular to the observer in front view. If that is the case, in the case of front view, we are able to see only length and height dimensions. Length and height dimension. Here, this green color shaded region is there, no? That particular region is visible in front view. This green color lines hatched or shaded region is there, no? That is, this inverted L shape is visible in front view. In addition to that, this particular green color shaded region and this particular green color shaded region is visible in the front view. Visible in the front view. That is length, height. Length, height. Length and height in the front view. Then we will move towards top view. For seeing the top of the object, what we have to do? Observer has to see the top of the object. Say top view. Say top view. In the case of top view, for the observer, length and breadth is visible. Length and breadth. That is, this red color hatched image is visible in the top view. Red color hatched image is visible in the top view, whereas height is perpendicular to the observer. Even this height also perpendicular to the observer. This height also perpendicular to the observer. If that is the case, the height dimension looks like a point in top view. That is, this total height looks like a point. This total height also looks like a point. This total height also looks like a point. If this is the case, then in top view, this inverted L shape plus this particular hatched rectangle and this particular hatched rectangle. That is, this red color hatched region is visible in the top view. This red color hatched region is visible, say this inverted L shape and this rectangle, and this particular rectangle is visible in the top view, and the top view is projected onto the horizontal plane. Then we'll analyze the side view. In the case of side view, breadth and height is visible. Side view. In the case of side view, we are able to see non-shaded region. Say this height, breadth, height, breadth, height, breadth, height. This non-shaded region and this non-shaded region also visible. This non-shaded region, this white color non-shaded region is visible in the side view. That is 72 breadth, 48 height, and again 24 breadth, 16 down, 24 breadth, 16 down, 24 breadth, 16 down. This particular region plus this particular non-shaded region is visible in the side view. Now we'll see how to draw front view, top view and side view for this particular pictorial drawing. As a first step, draw XY line. As a first step, draw XY line. Say X, Y. After that, see the image of front view. See the image of front view. Image in the case of front view, we are able to see 104 length and 48 height, then 24 length, down 32 height, and again 80 length, again 16 down height, 16 down height. So after drawing the XY line with a gap of 20 to 30 mm from the XY line, draw front view. The length of the front view is 104. So with a measurement of 104, draw length line. Then this height, how much? 48. After that, length 104, 48, 24, and then down 32, and then length 80, and again down 16. After drawing this inverted L shape, this green shaded region, even this particular rectangle also visible. As this breadth line is a point, it looks like this particular rectangle is placed over this first step. So the height of this rectangle is 16 and height is 16 and length is 80. Height is how much? 16 and length is 80. After that, as this breadth is point, even this breadth also point, then this particular step looks like placed over there. So height of this particular step is 16 and length is 80. So drawing the front view is over. Then we'll move towards top view. So before drawing the top view, draw projectors from the front view towards the horizontal plane. Towards the horizontal plane. After drawing the projectors, then see the top of the object. that is we are drawing top view. So in the case of top view, we are able to see this length and breadth. Length is how much? 104, and breadth is 72, and again length 24, and again breadth 48, and again length 80, and again breadth 24. Say length as 104, this length is 104, and again this breadth 72, again breadth is, again length is, this breadth is 72, and again this length is 24, and breadth 48, that is length 104, breadth 72, and length 24, and again breadth 48, and again length 80, and again breadth 24. Next, this inverted L shape, that red color shaded region is visible in the top view. As height is 0, that means point, and here also it looks like height looks like a point. If that is the case, then we are able to see this particular rectangle. This particular rectangle breadth is how much? 24, and length is 80. So from here, with a breadth of 24 and a length of 80, draw the rectangle. After that, this height is a point, even this height also point, even this height also point. So we are able to see this particular red color shaded region in top view. So this breadth is how much? 24, and length is 80. After drawing the top view, then what you have to do? After drawing the top view, what you have to do? Draw another reference line for drawing the profile plane. Another reference line for drawing the profile plane. Say x1, y1, x1, y1, x1, y1. After that, draw 45 degrees line at the intersection point of xy and x1, y1 line. After that, draw projectors from the top view to the 45 degrees line. After drawing 45 degrees line as well as projectors from the top view, locate the intersection points on the inclined line. From those points on the inclined line, draw projectors towards the profile plane. Then drop projectors from the front view also. All these projectors are with 2H pencil. After drawing the projectors, then see the side view of the object. After drawing the projectors, see the side view of the object. See the side view of the object. In the case of side view, we are able to see this breadth and this height. This breadth, height, breadth, height, breadth, height, breadth, height. This particular non-shaded region is visible in the side view, and this particular say breadth as 48 and height as 32 also visible. I mean this particular portion is also not shaded, no, that region also visible in the side view. So here what I want to say, in the case of top view, this is the breadth, no, this breadth is transferred from top view to the profile plane, and this height is transferred from front view to the profile plane for drawing the side view. I mean this height is transferred to profile plane and this breadth is transferred to profile plane. For height 48, breadth 72, draw a line with a height of 48 and a breadth of 72. Then again breadth is 24, height as 16 down, breadth 24 right, 16 down, height, breadth 24 right, 16 down. Then drawing this non-shaded region is over. Then what about this, as this length is a point, then this particular breadth looks like placed over there and this height is placed over this particular portion. So this breadth is how much? 48 is visible, and height as 32 from this point to there also visible. After drawing the front view, top view and side view, we have to do the dimensioning. Generally in the case of dimensioning, if length is shown in the front view, then no need to show that particular length in the top view. That is, dimensioning should not be repeated. Say here 24, 104. And then breadth, (72). 24, 24, and height height 48, this particular step height 16, this one also 16. Then you can print here, say front view, here side view, then top view. Okay, dear students, uh, okay, dear students, that's about projecting the orthographic projections from a three-dimensional object: front view, top view, side view. Front view, top view, side view. And front view is above the xy line, top view is below the xy line, side view is comes adjacent to the front view. This is the case we used under first angle projection. That's about converting pictorial view into orthographic projections. Hope everyone understood well. Thank you very much.